Okay, now we are going to start the new unit, Unit 4, trick, and we are going to start with special angles. Okay? Now, just to refresh your memory, remember in any right triangle, we can use primary trig ratios. If it's not a right triangle, forget about these ratios, sine, cos, and tan. Now, again, to refresh your memory, the angle which is 90 degrees is usually shown with a square, and the side in front of it is called the hypotenuse. That's reserved for the right triangle. So this side, which is in front of 90, is always called hypotenuse. There are two other angles involved, one which is here, the other one is here. Now, depending on these two angles, you can have opposite and adjacent sides. For instance, if you look at x, the side which is opposite to it is the side which is right in front of it. This one is already reserved as hypotenuse, so the only side which is left is this side, which we call the adjacent side. Now, if I change the angle, other than the 90 degrees angle, meaning if I go to this angle, the adjacent, which was previously to this angle, becomes the opposite to this angle. And the opposite, which was to this angle, becomes the adjacent to this angle. Now, based on these, I can define Sohcahtoa, if you remember, which was an acronym which was easy to memorize these three ratios. S stands for sine, O stands for opposite, and H stands for hypotenuse. C stands for cosine, A stands for adjacent, and H, as usual, hypotenuse. T stands for tan, O stands for opposite, and A stands for adjacent. That was what you learned last year. Now, what you are going to learn here is going to be ways of finding angles, any angles between 0 and 360 degrees. You used to be dependent on using the calculator. Now that one is gone. Now you have to be able to memorize some special angles, which I'm going to show you easy way of memorizing it. Or even when you get the unit test, you can just write it down, and then you don't really need to memorize those angles. Now, to be able to define these angles from 0 to 360 degrees without using the calculator, we are going to start defining what we call a unit circle. It's very easy. It's a circle with the radius equal to 1. That's it. That's what we call a unit circle. So in this circle that you have, the radius is equal to 1. Now the circle is centered at the origin, and it crosses the x and y axis at 1, 1, -1, and -1. Let's consider a unit circle which is shown here. Let's say the coordinate here of A is xy. Okay? Unknown. Now, this coordinate x is represented here by this value is x, and this value, if I find the y, this is y. Okay? Now, consider this angle here. If you remember from grade 10, I can write the sine of this angle. Okay? Let's call this angle theta. Okay? I can write that sine theta is equal to opposite, which is equal to AB, which is the same as y, divided by hypotenuse. But remember, this is a special type of circle, unit circle. So the radius is equal to 1. So I can say from here that y is equal to sine theta. The same way I can write cos theta is equal to adjacent, which is x, divided by the radius, which is the hypotenuse, 1. So from here I get that x is equal to cos theta. Now, you may say, why do I need to know this one? Look at the coordinate of the point, x and y. So this means that for a unit circle, any point on the circumference of the circle, the x-coordinate represents the cosine of the angle that the radius makes with the positive x-axis. And the y-coordinate of the point is the sine of that angle. Okay? So just remember this one. X is represented by cos of that angle, which is theta here, and y is the sine of that angle. Now, the first definition is called the initial arm. The initial arm is the side which is fallen on the positive x-axis. So, if I want to represent an angle in my unit circle, the side which is on the positive x-axis is called the initial arm. Now, we have a convention here in math that if I move this initial arm against the anti-clockwise, meaning this way, then the angle is positive. If I move it clockwise, the angle is negative. So remember, going anti-clockwise, the angle is positive. Going clockwise, the angle is negative. So if this angle is 30, then I say it's positive 30. If I go in anti-clockwise, and if this angle, let's say, is 60, this is really negative 60. Because I'm going in the same direction as the clock. Okay? Now, the arm which connects the point on the circumference from the origin is called the terminal arm. This is the angle that we are looking for. So this is the initial arm which stays on the positive x-axis, and this is the one that we call the terminal arm. And it stops because this angle equals, what we are talking about here. Now, when your terminal arm and the initial arm are such a way that the initial arm, okay, is on the positive, x-axis, and the terminal arm rotates, as I said, counterclockwise, the angle is positive. When it rotates clockwise, the angle is negative. Okay? Now, we define standard position of an angle is when the initial arm stays on the positive x-axis. Now, this means that if I have my, let's say, unit circle like this one, if the initial arm here and the other arm, okay, is here, then this is what we call standard position. But remember, I can have angles like this one. But this is not really standard position because this side is not on the positive x-axis. Everybody understood, I hope. Very simple. Now, the last definition before we start doing some examples is what we call a reference angle, is the one that, again, the initial arm is on the positive x-axis. This is what we call a reference angle. So in this example that we had, this is called a reference angle because this arm, the initial one, stays on the positive x-axis. Everybody okay? This is just definition. Okay, the first example. I want you to prove that in any triangle, a right triangle, if two angles are 45 degrees, okay, then the hypotenuse is square root times either leg. Okay, the length of the hypotenuse is square root of 2 times the other two legs. Just go ahead and see if you can prove it. Okay, now we have a right triangle with angle 90 here. This one is 45, and this one is 45. Since two angles are equal, the triangle is isosceles, so two sides are equal. So let's call this one A. Obviously, this guy is A2. Let's call this one x, which is hypotenuse. I can use the Pythagorean theorem. I can say x squared is equal to a squared plus a squared, which is equal to 2a squared. Now I take the square root of both sides. I say x is a square root of 2, which is what exactly is required from us. Now, there is a special value for a, which we can set to be 1. The reason that we will set a to be 1 is the unit circle. So if a is 1, then obviously the hypotenuse is x is equal to 1 square root of 2, which is square root of 2. So we just remember this one. If a is 1, meaning this guy is 1, this guy is 1, then this one is square root of 2. Okay, next example. Suppose we have a right triangle. Let me show the right triangle like this. So this is my right triangle. This is the right angle. Let's say this is 60, and this is my 30. Okay? What I have to prove here is that the hypotenuse, which is here, is twice in length than the smaller, side, which is this one, okay? And this side is square root of 3 times the shortest side. This is the proof. What I'm going to do is that you can look at it this way. I'm going to rotate this triangle about this side. So I'm going to have another triangle like this one. Everybody okay? Now, when I do that, it is obvious that this side, which is here, is equal to this side. Okay? This angle 30 is the same as this angle 30. This angle is 60. Now, if you look at this one, this angle is 60 degrees because 30 plus 30 is 60. This angle is 60, this angle is 60. So automatically it tells you that this is an equilateral triangle. 3 sides are equal. Okay? Now, let's assume that this side is A, this side is A, and this side is A, because this is equilateral. Okay? I know that this side, the whole thing here is A, so half of it is going to be here. So this is A over 2, and this guy is A over 2. I know this side is A, this side is A over 2. Okay? I can write the Pythagorean theorem here. Okay, now, let's say this side to be x. I can write the Pythagorean theorem here as a squared is equal to a over 2 squared plus x squared. Remember, this side is a, this side is a over 2, and this side we assigned x. So I can say that x squared is equal to a squared minus a over 2 squared is going to give me a squared over 4. Now, a squared can be written as 4a squared over 4. So 4a squared over 4 minus a squared is 3a squared over 4. Taking the square root of both sides, I'm going to get x is equal to a over 2 square root of 3. I know this is a. I know this is a over 2, right? Because I just flipped it. Let's call this one x. I can write a squared is equal to a over 2 squared plus x squared, Pythagorean Theorem. Okay? Now, a over 2 squared is a squared over 4, right? Right? So which is this guy. Now, I'm going to bring this one to the left. I get a squared minus a squared over 4. But a squared minus a squared over 4 is the same as 4a squared over 4, because a squared is the same as 4 over 4 times a squared, right? Make sense? I'm just trying to have the same denominator here, okay? Now, 4a squared over 4 minus a squared over 4 is going to give you 3a squared over 4. Then I take the square root of both sides to find x, and I get x is a over 2 square root of 3. Okay? Now, you're done. We proved it. Now, you may say, how did you prove it? I mean, you just showed, this guy is a over 2 square root of 3. Now, we just found that x is a over 2 square root of 3. So this is telling us that if the hypotenuse is a, the longer side is a over 2, meaning it's half of the hypotenuse. And also the shorter leg is a over 2 square root of 3, which is exactly what this is asking us to prove. That the hypotenuse is twice as long as the shorter leg, okay? And you can see that if the hypotenuse is a, the shorter leg is a over 2, meaning hypotenuse is twice the size of the shorter leg. And also, the longer leg is square root of 3 times the shorter leg. The shorter leg was a over 2 here, this one. So the x, which is the longer one, is square root of 3 times a over 2. So we proved this one. Okay, now let's talk about the unit circle, which is divided into different angles, like the one which is shown here. Let's go ahead and find why the coordinate of this point is square root of 3 over 2 and 1 over 2. Remember that this angle is 30 degrees. So automatically, if this angle is 30 degrees, if I draw a perpendicular line here, this angle is going to be 60 degrees. Now, we just proved that for any 30, 60, 90 degrees triangle, the hypotenuse is twice the size of the shortest leg, and the longer leg is square root of 3 times the shorter one. Now, remember that in a unit circle, this radius is 1. So this means that the shortest leg, which is this guy here, is going to be 1 over 2. And this means that the longer one, which is here, is going to be square root of 3 times 1 over 2. And if you look at the points here, the y coordinate is 1 over 2, which is this guy. And the x coordinate is square root of 3 over 2, which is this one. Now for the next angle, let's say 45 degrees, which is this one, this angle. I'm going to again draw the perpendicular line. So I'm going to have a triangle, a right triangle. One angle is 45, which is here. The other one automatically becomes 45. We just proved that for a right triangle with two angles equal to 45, the hypotenuse is going to be square root 2 of any one of the legs. So this means that if this guy, the hypotenuse is 1, because it's a unit circle, this is going to be 1 over square root of 2, and this is going to be 1 over square root of 2, because square root of 2 times 1 over square root of 2 gives you 1. Now you may say, okay, 1 over square root of 2 doesn't look like square root of 2 over 2. It's very easy to simplify this one by multiplying the numerator and denominator by square root of 2. You get square root of 2 divided by square root of 2 times square root of 2 gives you 2. So it's square root of 2 divided by 2. Now the other side in second quadrant, which is right here in this part of the graph, if I take any point, let's say 60 degrees, and then I reflect it on the y-axis, I get the 120 degrees here. If you look at these 2 points, the y-coordinate of these 2 points is going to stay the same. So this means that the y-coordinate of 60 degrees is going to be the same for 120 degrees. But the only difference is that the x-coordinate here, which is this side, is going to be the same length in absolute value, but it's going to be negative side of x-axis. So it's going to be negative 1 over 2. And the same is true for any other angle. If I have, 45 degrees, okay, I'm going to reflect it on the y-axis. I'm going to get 135 degrees, okay? And this one, the y coordinates are going to stay the same, but the x coordinates are going to be flipped in sign. Now, the only one that I haven't talked about is the 0 degrees and the 90 degrees angles, which is easy to see because 0 degrees, okay, which is here, remember that the sine is the y coordinate of the point, and we know the y coordinate of the point here is 0, so we can say that the sine of the 0 angle is 0, and the cosine of the angle, which is cosine of 0, is the x coordinate of the point, which is 1. And the same thing is true for point 0, 1, because the y coordinate of the point is 1, and the point is on the y axis, so the x coordinate is 0. And again, we go with the same terminology that the x coordinate is always cos of the angle, and the y coordinate is the x of the point. So this proves also that the sine of 90 is 1, and the cosine of 90 is going to be 0. The third example that we are going to do is to use a unit circle, and you are supposed to find the exact values of the trig ratios for 0, 90, 180, and 270. Okay? This means that you are not allowed to use calculator. So the way you do it is simple, is that you are going to draw this unit circle. You know that this is your unit circle. This point has the coordinate 1, 0. This is 0, 1. This is negative 1, 0. And this is 0 and negative 1. Now, we know that x coordinate is the x coordinate is the cosine of the angle. So looking at this one, we can see that cos 0 is 1, and the sine is going to be, sine of 0 is going to be the y coordinate, which is 0. Okay? The same way we can go here and we can find that sine 90 is going to be the y coordinate, which is 1, and cos 90 is going to be the x coordinate, which is going to be 0. Now, I'm not going to go through the other 2 points. You can figure it out easily. There is no problem, But the only thing is that, remember, this angle becomes 180 degrees. Okay? And this point, the angle is 270 degrees. Okay? The only thing that I have to mention here is how to find the tan of these angles. Remember, by definition, tan is equal to sine over cosine. Okay? Now, for angle, let's say 0, the sine is 0. As you can see here, the sine is 0, and the cos is 1. So we can say that tan 0 is 0 over 1, which is equal to 0. Okay? But for the case of 90, tan 90 is equal to sine divided by cos. Sine of 90 is 1, but the cos of 90 is 0. This means that tan 90 is undefined. If you use your calculator, you will see you will get an error message here, and so forth. So for any point that you will find the sine cos, then you can just divide it to find the tan of that angle. Okay, the last example, you have air traffic controller, which is located at the origin of the unit circle. This is the air traffic controller. And he observes that the value air flight is 20 kilometers due east of the control tower. So if this one is east, this one is north, this one is west, and this one is south, okay? Then the value air is 20 kilometers due east. So let's say, this is the value air, call it VA. While a first-class air flight is 25 kilometers in a direction of 10 degrees west of north. If this is north, west of north is this way. So the other one is going to be 10 degrees, which is 10 here, which is going to be 10 degrees here from the north. The question is that what is the angle of separation of the two aircraft as seen from the tower? The angle is this one, which is going to be 90 plus 10, which is 100 degrees. Okay? Now, the next one, which we are not going to do here because we don't have the graph paper, you have to use a grid, a graph paper which has the grid lines, and you have to use your ruler to really measure the distance. But it says construct a unit circle to determine the cosine of the angle in part A, meaning the cosine of 100 degrees. To do that one, what you usually do is that you draw a unit circle. Let's say your unit circle looks like this one. Then you have to find what is the x-coordinate of this point by using your ruler to measure exactly how much is this one. You know that the radius of this circle is 1 because this is a unit circle. Then by measuring this distance, which is your x-coordinate, you can find the cosine of angle 100. Okay?